Mabuhay, Makilingers! Hello, grade 9 students! I am Ma'am Lourdes Ordiliano, your virtual teacher for today. Come and join me in welcoming this day with brand new learning experience. Today, we are going to explore the step-by-step procedures of solving equations involving radical expressions.
At the end of the lesson, you are expected to, first, differentiate a radical equation from a non-radical equation. Second, solve radical equations. Third, solve problem involving radical equation.
To begin with our lesson, let us first differentiate a radical equation from a non-radical equation. Are you ready? If you are, then let us perform the activity.
To perform the activity number 1, we are going to group the equations in set A and set B based on their similarities. If you are ready, we are going to start at the count of 3. 1, 2, 3, start!
How did you find our first activity? I hope that you find it easy to answer. Now, let us check if you have answered it correctly.
The first set of equations must obtain the following. Cube root of x is equals to 3 cube root of 7. 2 square root of x is equals to x plus 1. Cube root of 2x plus 9 minus 5 is equals to 0. While the second set of the equation consists of the following. 3 plus 2x square root of 2 is equals to 10. Cube root of 5 plus x is equals to negative 3x. Square root of 7 is equals to x. What characteristic does the set A have? Nice answer! Some variable x is found in the radicand. How about the characteristic of the equation on set B? Very good! Variable x is not part of radicand.
We have already identified the different characteristics of the two sets of equations. What set do you think is the set of radical equation? Very good! Set A is the set of radical equations, while set B is a set of non-radical equations. Let us define first what is a radical equation. A radical equation is an equation whose angular quantity is in the radical. After knowing what is a radical equation, let us now explore how to solve radical equation by doing the second activity.
Let us call this activity Lights, Camera, Action. We will be making use of a made-up scene and we will be making use of it to solve the equation that will follow. In the movie, the villain is supposed to fall off the cliff. His body double, a stuntman, wants to know how high the cliff is. Drops a stone to the water below. It takes the stone 2 seconds to hit the water from the top of the cliff. How high is the cliff? Use the formula T is equals to the square root of D over 16, where T is equals to time in seconds, D is equals to height in feet.
Remember, a free-falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be in a state of free fall. So based on the problem of free falling objects, how are we going to find for the height of the cliff?
To find the height of the cliff, we will be using the formula T is equals to the square root of D over 16. Then substitute 2 for T in the formula for free falling objects. It will become 2 is equals to the square root of D over 16. This is an example of radical equation. Squaring both sides of the equation, we have the quantity of 2 square is equals to the quantity of the square root of D over 16 squared. Multiply both sides by 16. The quantity of D over 16 times 16 is equals to 4 times 16. The results will be D is equals to 64. Therefore, the cliff is 64 feet high.
At this moment, we will get to know what are the things we must consider in answering the problem related to radical equation.
The following are the steps in solving radical equations. First, write the equation such that the radical containing the unknown is on one side of the equation. Second, combine similar terms. Third, raise both sides of the equation to a power same as the index of the radical. The equation should be free of radical to complete the solution. Fourth, check if the value of values obtained will make the original equation true.
Now, let us try solving the following radical equations by following the 4 steps.
Given cube root of 2x plus 9 minus 5 is equals to 0. Based from our step 1, using addition property of equality, we will add 5 to both sides of the equation. The resulting equation would be cube root of 2x plus 9 is equals to 5. We have separated the radical term to the constant term. Because the equation does not contain similar terms, we will proceed to step number 3. Cube root of 2x plus 9 is equals to 5 will be the quantity of cube root of 2x plus 9 cubed is equals to 5 cubed. Because our index is 3, we will raise both sides of the equation to 3. The resulting equation will be 2x plus 9 is equals to 125. We can now solve for x by subtracting 9 to both sides of the equation by addition property of equality. Then we have now 2x is equals to 116. By multiplying the multiplicative inverse of 2, that is 1/2, by both sides of the equation, the value of x will be 58. For the last step, we will substitute the value of x to the original equation to see if the equation will be true. As we can see in the solution, the value of x that is 58 make our equation true.
Were you able to follow the different steps? To make it clearer, let us try to solve another problem.
The square root of the sum of two consecutive odd integers is equals to 6. Find the larger integer. For us to solve the problem, we must understand the problem first. Then write the radical equation and solve it.
And to understand the problem, we must carefully read it, identify the given, and what is asked.
Based on our problem, let x be the smaller odd integer. X plus 2 be the larger odd integer. We will be solving for the value of the larger odd integer. In order to do this, we will equate the square root of the sum of these integers to 6. We can now write the equation based on the given. The equation form is the square root of x plus the quantity of x plus 2 is equals to 6. As we can see, it is a sample of radical equation because our unknown variable is part of the radicand.
We already have the radical equation that will help us determine the larger integer. We will now apply the fourth step in solving the radical equation.
Because the unknown variable is already separated on both sides of the equation, we will proceed to the second step by combining like terms. If we combine, the results will be the square root of 2x plus 2 is equals to 6. We can now proceed to step 3 by raising both sides of the equation by the value of the index, and that is 2. The equation now will be 2x plus 2 is equals to 36. Applying addition property of equality, we will add negative 2 to both sides of the equation. It will become 2x is equals to 34. Multiply both sides of the equation by 1/2, the multiplicative inverse of the numerical coefficient of x, that is 2. The result is x is equals to 17, the smaller integer value. Therefore, x plus 2 will be 17 plus 2, and that is 19. 19 is the larger odd integer.
To check if our answer is correct, we must perform the last step, and that is to see if the value will make our equation true.
Based on our solution, we can say that the value we obtain make the equation true.
Were you able to understand how to solve the radical equation? Let's see how far you have learned about the lesson.
Are you ready, grade 9? Let us try answering the following questions by selecting the letter of the correct answers. Good luck!
Very good, class. You really learned and understand what we have discussed today. So, these are some important concepts that we should remember in solving radical equation. Write the equation such that radical containing the unknown is on one side of the equation. Second, combine like terms. Raise both sides of the equation to a power same as the index of the radical. The equation should be free of the radical to complete the solution. Check if the value or the values obtained will make the original equation true. Were you able to cope with the lesson for today? If so, that's great! If you find this difficult, you shouldn't worry because consistent practice in solving the problem would really be of great help. Just keep on practicing. And don't forget to write something in your journal about your day's reflection. That concludes this instructional session. I'm Ma'am Maria Lourdes,